All right. Hi, everybody. Today we're going to talk about time series data and time series databases. And for that, I have the founder and CEO of TD Engine with me, Jeff Tao. He's going to tell us what are time series databases, why are they so great, and why do we might want to use one. We're going to go through questions in this. So if you have questions, I already see a few people in the chat. Drop the questions in the chat and we're going to take care of them. Do me a favor before I bring in Jeff here. In the description of this video, I added Jeff's Twitter and I added Jeff's LinkedIn. So please do me a favor and give him a follow. He's posting very interesting stuff around time series data and time series databases. So let me bring in Jeff. Hi, Jeff.
Hello.
How's it going?
Good. Very good.
Very nice to have you here. So yeah, time series data, time series databases. You're the expert. Can you tell us a few words about your journey up to here to be the founder and CEO of TD Engine?
Okay. Very good question, Andrew. So, more than almost 7 years ago, my last startup is for smart devices. I designed a few smart devices for health, like monitor your blood pressure, glucose, and also weight. Those smart devices generate lots of time series data. At that time, I just used my SQL to save those data. Once I got almost like 200,000 users, my SQL becomes very slow process those data. So then suddenly I found that there is a time series database there. At that time, we already have InfluxDB, okay? But after I tried the InfluxDB, I think they're not good enough. So I think why I don't build my own one. Then I started my third startup, it's called the TD Engine. So I from day one, I want to have a very good performance and also have some extra features for those time series data. Now it's already 6 years, okay? And also 4 years back, I open sourced our TD Engine. Now we already got over 200,000 stars and on GitHub, and also we have over 300,000 installations from over 50 countries. Yeah, that's my journey.
Okay, wow, that's a like a very quick start of TD Engine, right? Because I was looking at DB engines. That's my go-to always. Like, okay, now to see what's going on with it, different time series or different database types, and yeah, okay, very nice. So time series data, you mentioned smart devices. That's also something that I'm coming from, right? I'm coming from the IoT world. I was working with machine data a lot. So that was the natural move then to actual time series data for you.
Yes.
Now today, for the use cases of that kind of data where you have measurements and then you have basically or taking measurements every increment of time, every second, every up to milliseconds or even faster, right? What would you say are the use cases for these types of databases mostly?
Oh, like for our TD Engine, we focus more on IoT and the industry internet. If you guys check our website, we use like a smart meter as an example, because every smart meter generate a data point for every 50 minutes. Okay, like in China, there are over 1 billion smart meters. They generate huge amount of data. You need a purpose-built database to handle those huge amount of data. Regular, like a standard MySQL, Postgres, or even MongoDB cannot handle that. That's one case. Another case, like even still for power industry, like for window turbine or solar panel, those clean energies generate huge amount of data. And one case is even for academic research, seismology. Okay,
Okay.
they put so many sensors in the earth to detect the vibration. Okay, that's a huge amount of data, even in milliseconds, like a sampling rate. Huge, Another case is like for like logistics. You want to know the location for each truck, right? You want to track the location for each truck or for each taxi. Those are time series data. And another traditional case is stock market. The stock change.
Stock market,
it's time series data. Another example I can give is even like for so many heavy equipment, like for crane or elevator or boiler. Now they are also internet connected. So you can have a remote control for your elevator. You can check the elevator status. You can check the boiler status. Those are time series data. Okay, so time series data even everywhere. One example, nobody think bicycle is even internet connected, right?
It's true. So, with e-bikes, yeah, absolutely.
Even bicycle all those vehicles are internet connected. They generate a huge amount of data, and also like even for self-driving, right? Autonomous driving. Huge amount of data. So we need a new tool to process those data.
Yeah. Why do you what are the typical issues that you have found with if let's say you have a lot of time series data and you want to store this and then retrieve it and generate graphs and analytics out of it? If you use a normal database, what are some problems that the people are going to face?
Performance, like for data ingestion. It's impossible for MySQL or Postgres to insert like 1 million data points in 1 second. But for time series database, it's very easy for them to handle like 1 million or 2 million or even 10 million. Like for TD engine, we can handle even 10 million data points per second, you know?
Yeah.
So that's very hard for regular database or general purpose database to do that. Because for time series database, they don't support transaction. Because for time series data, no update operation. Okay, or you don't support delete or update, you don't support transaction. It's much more efficient. Okay, performance. Performance is first issue. Second thing is you still sometimes people say my data volume is not big at all. I only have 10 devices. I can still use MySQL to handle my data, right? That's true. But for time series data, you need a very spatial analytics. For example, I want to calculate the rate of change, right? Or I want to calculate the accumulated sum. MySQL don't provide those functions. Okay, and also sometimes for time series data, you need to do interpolation. For example, I have a data point at the 10 o'clock, at another data point at the 10:05, but I want to know your location at the 10:02. You can only do interpolation. Standard database don't do that, right? So, and also like a time series database always provide all kinds of windows function, like a sliding window. Please tell me what's the average like power consumption for every 5 minutes. Right? That's kind of called like a sliding window. And also there are all kinds of other windows like session window, state window, because when your machine stays in some specific state, you want to do some analytics. So like for example, it's on or off. I want to do some analysis. So that's different. So MySQL, Postgres, MongoDB don't provide those kind of features. So even your data volume is not big, if your data is time series data, you better still use time series database. You know?
Yeah, because with a normal database, basically when you put in the row, the time is just another column, and then you have to very complicated queries to actually get the information out, right?
Yeah.
Which is with the time series database is very simple, where the time is the leading factor. It's
Yeah.
the main thing that
Another
matters.
very good feature for time series database is retention policy. Because you only want to keep your data for a period of time. Maybe you just want to keep your data for 3 months or for 1 year. Then you want to delete the data automatically. General purpose database don't do that, but time series database always has this feature. You can set your retention policy.
Because let's face it, it can get very expensive if you want to keep all the data that you get.
Yes.
This would be problematic. Can you like aggregate the data then automatically? I actually haven't thought about this. It just comes up in my mind now. Like that you say, okay, I'm putting the data retention in for 30 days, and after 30 days, I'm taking my millisecond data and I'm automatically going to make an average for every second or every minute or something.
Yes. For time series data, lots of people want to do downsampling. Maybe I just want to keep my raw data for 1 month, but I want to keep a downsampling data for 10 years, right? For example, like a temperature, okay, humidity. I just want to keep the average temperature for 1 single day. Maybe I can keep those data for 10 years. But the raw data, maybe my temperature sensor can record the temperature every 1 minute. I don't need that. I just need the average temperature. So,
but you would do that then before, so this would not be something that is automatic with the retention, but that is something you say every day I'm going to calculate or I'm going to downsample my data and store this then in another part of the time series database to store it for a longer time.
Yes. So time series database always provides this kind of feature. So it's very, otherwise your application got to do that by yourself.
Yeah.
Right? It's painful.
Can be difficult. There's a question from Irvin here. Couldn't you use a columnar database to insert time series data? What do you think about that?
Of course, columnar. First of all, as far as I know, all those time series database are column-based. Column-based their storage. Okay, you can use ClickHouse to store those time series data. Okay, of course. Okay, but they are still not efficient compared with the time series database.
Okay, so time series database basically you have your, when you think of a normal table, you have your you have your timestamp, let's say completely on the left, where there is it's the main could we say the key column or the main column in this, and then you have your measurements from the sensors, for instance, as columns, but they stand on their own usually, right? These
actually, besides timestamp measurements, there sometimes you can associate the types or labels with each time series. For example, for each smart meter, every smart meter always has a location. For example, your home address, your office address, right? So the tags too. Sometimes you want to do aggregation based on those tags. Say, I want to get the total power consumption for whole California, or for San Jose in California, you know? Okay.
So that already leads to scalability, right? So how does this scale usually? Would this scale by device, or how does the scaling with the time series data? Well, in case of TD Engine, how do you do it?
Oh, so very good question. So actually, scalability is very important for time series database, because you 1 million or 10 million, even 100 million time series. Because of, like, for IoT case, you may have 1 billion smart meters. Every smart meter is a time series. So it's called a high cardinality issue. Okay. So to solve this high cardinality issue, you must have a distributed design. You need shard. You need to provide sharding. Every shard contains the data from a number of devices. Okay. So like for TD Engine, we just use consistent hash. Once I know your device, I just use your device ID, hash your device ID, then decide which shard can save your data. When we query, and also we use consistent hash to find where you are, read the data out, right? So you must have a distributed design. And even for like time series data, after you have a distributed design, you may still have trouble because those metadata are huge. Each time series have some static tags or labels. For example, for smart meter, you may have locations and a model number and many other attributes. If you have 1 billion smart meters, think about how big the size of the metadata is huge. So like for our TD Engine, we have a distributed design for metadata too, not only for time series data. Otherwise, it will be very, very slow to aggregate the data. So you must have a very good scalability. That's a big challenge for time series database. Like for Timescale or even for the InfluxDB, they still have a high cardinality issue. But like for our TD Engine, we can support like 1 billion devices without any problem.
Is that because like when I did my video, what I found very interesting is basically that you create one table for each device. Is that because it's so easy to distribute that basically every device is its own table, that you can say, okay, I'm going to put this on this server, I'm going to put this here and here and here, and
yeah, of course. We just use device ID to decide which load they want to save the data. And but our data model is called one device, one table. This data model is very good, has a very good performance for data ingestion, and also has a very low query latency. Okay, and also has a very good data compression ratio, because once you have one table for one device, the data from one single device are stored continuous together. So the data writing or insert operation becomes a data appending operation. It's much fast. And also the data points from one single device are stored together. So when you do query, one IO operation can read out a many number of data points. So it's very efficient. And another good advantage is data compression, because the data from one single device not much change. For example, for your smart meter at your home, the power almost the same, right?
Yeah. Or the temperature is
like a temperature. There's some fluctuations, but very, very small. Then it's very easy to compress. So by one table, one device, you can achieve very higher data compression ratio. So that's why our TD Engine has a very high data compression ratio. Okay.
Yeah. Back to the querying. When I remember when I started working with time series data, and we were thinking about, okay, how can we actually store the data and then retrieve the data? One thing that we found was when you retrieve time series data, you always like retrieve it in sequence, right? Like you said, you have a starting timestamp and you have an end timestamp, and everything in between you read. So if everything is, or if the data is together, like in a storage file from that device, it's very easy to actually just say, okay, take the start, take the end, and everything in between, and then whoop, you have it.
Yes. Right. So by one table for one table for one device, it's much easier. Yeah.
Also with the storage, you said, well, now let's quickly keep on scalability. When I was looking at the interface, is you can actually define how large the files should be, right?
Oh,
for
okay. Yes, we don't configure how big the file is. We only configure like how many days of data you want to keep per
okay.
file.
Yeah, that was it. Yeah.
Yeah.
Cool, yeah.
So like for example, you one file only keep 1 week data. So for for each year, then we have 52 files. Okay.
Yeah. So the engineer should then it comes back to the engineer. The engineer needs to understand, okay, how much data will I have or will I get per day? So that, because I'm guessing if you configure this wrong, then you will store a lot of data together and then you will get a bit in trouble if you have too much data, right?
Yeah.
So
So you
it's,
need to,
I'm sorry.
you need to tune your system, optimize
Yeah.
your system. Yeah.
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 Uh,
If the like each file contain like for example contain data from one single year, that's too much. Your data file will be huge. That's really good, you know. But if you only keep the like 1 hour data in one single file, then you have so many files in your system, you know, a lot good
that,
easier. Yeah,
yeah,
you know.
I'm guessing you run then into the small files problem that is very old,
Yes.
right?
Yeah.
The
Yes.
system has to look into so many files that it takes forever to
Yes.
get results.
Then you put a big burden on the file system. You need to open so many files. It will slow down your system. So
How
that kind of trade-off.
how
Yeah.
do you handle the tuning? Is there like something in TD Engine where you can see, okay, this is my performance, or like as a developer, I'm just what we're talking, I'm thinking like, okay, I have a lot of data and I know my devices, I understand how much data is coming in. I set the time to keep in a file to like 10 days. But how can I somehow see somewhere in the system, I should tune it smaller, or that, you know what I mean? Can I do some performance tuning
Oh,
somehow?
yeah. So I understand. So in our we give some suggestions to developers. Depends on how long you want to save your file, save your data. For example, if you want to save your file data for 1 year, I would suggest you just keep like maybe 300 files should be good, you know. But if you want to keep your data for 10 years, you don't want 3,000 files. You know,
Yeah.
that will be huge burden. Then, so depends on how long you want to save your files.
Okay.
Okay.
Okay. And I think with time series data you mentioned earlier, and I want to point this out. I think that could be very interesting for the audience. Is the when you are working with time series data, you usually don't do like changes of the data, or how do we call this, reinserting? No.
Update the data. Update the
Yeah,
data.
exactly. Ugh.
Yeah.
That
Yeah.
you usually don't do update
Yeah,
processes, right?
TD Engine supports updates, but not efficient. So if you have so many updates for your data, our system will slow down. Okay,
Yeah.
but for IoT case, like for the real case, you won't have so many updates. If you have so many updates, I won't suggest you to use time series database. You should use just the standard database.
Yeah. Yeah, exactly. Yeah, but why would you usually, once something is measured and it's taken in and it's stored, like
Yeah.
it
Why
doesn't change.
it change, right? So
But that's actually something that people need to keep in mind, because the other way can also be that people are using a time series database, like you said, and they want to do a lot of updates, and then that's not the good approach for this, right? Or
yes.
the right database. Because like, and somebody mentioned here, like, it's a bit, we cannot go into this completely, like comparison to HBase for time series. But I remember back in the HBase days, it was the same thing, right? Because the data was all stored together, and it's in the time series database. It's meant for you have a start and the end, and you take everything in between. And then to make an update, it's very complicated to actually find the exact data point that you're looking for in that. So everybody keep that in mind. Time series databases for stuff that doesn't update, very good. For stuff that updates a lot.
But HBase is not good for time series data because HBase is a KV store, key value. For time series data, the key is the measurement plus the tags. Okay, for each data point, they always need to save the key. So first of all, the tags are stored redundant because the tags won't change. Okay, only measurement will be changed. So HBase has the data compression won't be good. Okay.
No, also, it doesn't have all the upsides, like you said, with the window function and everything. But back in the day, like 10 years ago, there were no really good time series databases around, and had to find something.
But the HBase has something good. It's because it's a scalable system. It's a distributed KV store. So that's why OpenTSDB still has many users, because OpenTSDB is built based on HBase. I can say the only advantage of OpenTSDB is scalable. It's scalability because HBase is scalable. So OpenTSDB is scalable.
Yeah. How do you do that? So usually when you set up TD Engine, and now we're not talking about the cloud, we can talk about that later. But let's say I'm setting up TD Engine in my AWS, and I'm getting instances for this. So how do I handle this setup usually?
Can you ask the question again, because the voice is cut?
So you can TD Engine you can also install by yourself, right? You have for instance a Docker container that you can install. So how are you handling the scaling in these kind of situations? Because you can scale, and we were talking about horizontal scaling. Like how does that work with TD Engine? Is there then some kind of a leader, or how is that handled?
You mean scalability?
Yeah.
Because we have a cluster edition, you can install multiple loads. Multiple loads work together as a cluster. So then we distribute the load workload to multiple loads.
Okay, so
right?
So
you can install TD Engine on multiple loads to form a cluster. Like for example, for one of our customer, they have like 20 nodes for one single database.
Okay. Oh.
So they can handle huge amount of data.
Okay, nice. Well then, because that's actually something that you mentioned. TSDB, they're the only one else that really can scale. I think that's also something where Influx is not really the best in the scaling area. So yeah, that was actually what you mentioned in the beginning. You developed TD Engine because the others had these problems. So what was that again? Was that also scaling?
Because in the at the year of 2016. I found the time series database. I think I can use time series database to handle our data from smart devices. Then I started the InfluxDB, and also I started Prometheus. Okay, I found it's not good enough, and also I checked the source code. Then I think for time series data, there is a big feature. For time series data, I found InfluxDB or Prometheus don't use this feature. It's each device, the data points from each device is just like a stream, just like a video stream, So I think, why don't we build one table for one device, for one stream? So, and also,
Yeah.
why don't we just use message queue for each stream to store those data? I think that's a very straightforward way to store those data. So
Yeah.
then I think I can write a new time series database to handle data very more efficiently.
There was also something that I found. You mentioned message queue, like how to get data, because with time series databases, the data usually comes in as a stream of measurements and from each
Yeah.
device. And while researching for my video, I saw Kafka. And I think
Yes.
we also talked about that before. Like that is something where, like, can you explain a bit what you're doing there with Kafka? How
Oh,
that works?
yeah. Actually, our internal data engine is more like a Kafka, because inside our TD engine, we build a message queue for each device, for each for each stream. We build our internal message queue. First
Mhm.
in, first out. Yeah.
Okay.
But compared with message queue, you still need to build your index for time series data. Okay. So sometimes the data points may arrive out of order. Okay. And also for message queue, it's unstructured data. For time series data inside our database, it's a structured data. You have columns. You have data type. For Kafka, they don't. That's unstructured. It's a message queue, right? You
Yeah.
know. So for Kafka, for message queue, they don't need to provide analytics functions. But for time series data, you need to provide analytics function. You need to calculate the sum, average, many
Yeah.
mathematical functions, right? But for the storage, actually almost the same. like a message queue. Because at least for our TD engine, our storage mechanism is almost the same as Kafka's. It's because we build a queue for each device or for each time for each data stream.
Uh-huh.
Okay.
Nice. Okay. But you can also,
The,
if data is coming in, from a Kafka source, you can also then directly put this into TD Engine, right?
yeah, of course, yeah. And also,
Because
based on our internal message queue, we provide other features too. Like we build an internal message queue. Then, based on this message queue, we support stream processing. Okay, real-time stream processing, and also we support data subscription, just like a Kafka. So application can subscribe your stream to get a notification right away when you have a new data point. You know, so
yeah.
all our design is based on the message queue. Actually, our TD engine, all our design is based on the message queue. And also, I can tell a little bit of story about a design, why I got this idea. Because I quit my job in Motorola, in 2008 in Chicago. I started my first business is for pushing platform for mobile messaging platform. Okay, in year 2008. Okay, so for each mobile, in my server side, the mobile may be offline, but some people send your message to your mobile. So I have to save your message on the server first, then push this message to your mobile. So in year 2008, I just build a distributed message queue, because I build a message queue for each mobile. You know, once your mobile is online, I push the message one by one to your mobile. Okay. So in year like 7 years ago, in year 2016, I suddenly realized time series data just like a message queue. Okay, so that's why I build a message queue for each device, one table, one table, one device. Yeah, because in year 2008, I built a queue for each mobile device. I got this idea
Okay.
from there. Okay.
Well, this is how it develops sometimes, right? You have a problem there, and then you take it over. And now I could use the same thought there and actually improve it and build it into
Yes.
something.
So by the end of year 2016, I realized why I can use my old code to build the new system. So my storage engine almost the same, but I build my analytics part. You know, because message queue is unstructured.
Yeah.
But for time series data, it's structured data. You need to support SQL, right? You need to build the, you need to provide lots of functions. That's so my whole platform is still different from my messaging push platform. Okay. But the basic idea is the same. In year 2008, it's for each mobile device, I build a queue. Now, for each smart device, I still build a queue.
Well,
Okay.
I mean, it's as you said, it's time series data. It's data that is coming, that is streaming in.
Yeah.
It works.
It's
There was a
easy.
question, Jeff, here. How do you deal with late arriving data or changes to
Oh,
values? Well, changes to values we don't have that much due to upstream ingestion, data processing errors.
okay. I can answer this question. So
Okay.
we handle out of order data, out of order. Okay. So in our storage engine, if the data out of order, we will have a small like a patch in the data file. So when we read the data out, we need to merge two blocks together because some data points are out of order. Like for Prometheus, they don't handle out of order data. Okay, InfluxDB can handle out of data. Timescale can handle out of the data, but Prometheus don't handle that. They just drop the data. Okay.
Okay. So upstream data processing, that was another one. One sec.
I cannot.
Well, that's no, that JR, can TD Engine scale horizontally on your local machine? That doesn't make sense. Like if you have the local machine, then you have one installation, and if you want to scale horizontally, then you are going to get multiple servers and install this on multiple servers. Like Jeff said, in a cluster, horizontal scaling on a single machine, that doesn't make any sense. There's one question about ingestion latency with data completeness when ingesting live data.
How to reconcile ingestion latency with data completeness? Oh, I don't know this question. Because
actually,
for data integrity, he's talking about data integrity. Because if your data packet is huge, of course the latency will be big. Like for example, you insert data points into a server, into TD Engine, but this data packet is like 1 megabyte data. It contains like many data points. Of course, your latency will be big because we need to store your 1 megabyte data into our engine, then return response to you.
Yeah.
The latency will be big. Okay.
But that's always the case. I mean, if you have time series data, usually the best case is if you have individual measurements that are coming in, then it's a very small like amount of data and the latency is very small. But if your device like needs to buffer for 10 minutes or for an hour and then you send a lot of data at once, of course you're going to have latency in this.
Yes.
It's
if you buffer your data for 10 minutes, of course your latency will be bigger. Yeah.
What else do we want to know? Let me quickly check my notes because I have a few notes. Cloud. So this is TD Engine is not just for like the local installation. You also offer a cloud service. No, right?
Yes.
That makes
we
it
have
very
cloud
easy.
service on AWS, Azure, and GCP. Yeah. And also
So
it's
that
free.
means
Everybody can register our cloud service free. Okay. Without a credit card, you can register the account.
so that means when I think about a company who wants to have a time series database, and they have the requirement that everything needs to be on AWS, they can come to TD Engine and they can then configure that this to run on AWS. But you're actually managing that environment, right?
Yes, it's fully managed service. Fully managed service.
How long?
Yeah,
So I'm
go
sorry.
ahead.
No, go on.
Go ahead. Yeah, once you can use your Gmail account or GitHub account to register. It can be ready in 20 minutes. In 20 seconds. Everything be ready. Then you can write your data, query your data. Yeah. It's very convenient.
I mean, everybody, you can also check out the video that I did. It's like super easy. It's very quick. But this is like, what do you think? What would be some of the, or what do you have on your timeline for next features for the cloud version? Like, is there something you want to put in there that you right now don't have, like a big feature?
Now, for our in the near future, we'll put a very nice feature for data scientists in our cloud service. Okay, we are going to put some public databases on our cloud. So all those data scientists can use Python to access those public data to run their own algorithm. For example, Python. Okay. So, and also like even Andrew, you can put some sample data on our cloud service. So your student can write their own algorithm to analyze those data. So it becomes like a public repository. But it's SQL. Okay. You can even use Jobit to analyze those data, to do time series data prediction, for example. So it will be there by the end of this month. We are going to put like a New York power consumption, like a power data in our cloud. So everybody can analyze New York power data, okay? Or maybe a New York taxi data. It's also public. So many data science students, they always try to practice their algorithms, right? So that will be very, very helpful. Yeah.
Let me know. Let me know when that is ready. I'm going to share this with my people. I think that could be also interesting for engineers to work a bit and to use dashboards on that data. Right?
Yeah.
That's also a big part.
Yeah. Otherwise, like in the current days, the teacher always give students an Excel file. Say, that's my data set. Right now, I want you to put the data set on our cloud. You know, then students can write SQL to download the data, or they just use Python, or they just use Jobit, you know, to analyze those data. It will be very convenient.
What do you see your customers like? Are they working more with dashboards, or are they working really more with Python that they analyze the data through code? What do you see most?
Dashboards. Most of them dashboard. But they do have some customers, they use Python to do some advanced analysis. But most of them just a dashboard. Yeah. Maybe 90%, maybe over 90%. They just dashboards.
For these use cases, a lot of time, or many people think, or no, let's say this the other way around. A lot of people think the data scientist needs to do everything and for all data types, and it's always the main use case. But very often, just having a dashboard, understanding what's going on, actually exploring data, right? That's a very big thing for companies to actually achieve.
So you always want to get some insight for your operation. So time series database is very good to monitor your operation. You want to know your operation status, right? So
yeah, that's true. That's true. The operations data is very important. There was one thing again about the latency, but I think live data latency may require you to drop data points if system falls behind any problem in my case. So is that a problem?
No, that's not a problem.
Huh?
No, it won't a problem. Why you want to drop data point? No.
Yeah, I don't understand as well.
Yeah, no.
Because the database, like how is that handled in TD Engine? I saw something like with write ahead log or something.
Yeah,
Like-
yeah. That's for data recovery.
Okay.
In case your computer crash, you need to restore those data, right? So write ahead log. Yeah.
Okay.
When you write the data, you always save data into write ahead log first.
Yeah. So usually if you put in a lot of data, you have latency, the database, let's say the database can't handle it because it's so much data and the latency goes up, the database doesn't drop any usually.
No, database won't drop the points.
Yeah,
so no.
But interestingly enough, for time series databases, how do you handle this? Like when you write data, could you accept that, like, or let's say the other way around. Very often with time series data, if one data point goes missing somewhere,
yeah,
who cares, right? How's TD Engine handling this? Is this also more like okay, we are not doing this on a transactional base, that the data is, you know what I mean? That you could, in worst case, you could lose a data point, but then.
First of all, for our TD Engine, once your data is right into our system, and also TD Engine give you acknowledgement, it won't be lost at all. Okay. Once TD Engine tell you it's successful, the data points will always be there.
Yeah.
Okay. It won't be lost. But if you never got my confirmation, if your application doesn't get my acknowledgement, it may be lost. Okay.
Yeah. Okay.
Once you get acknowledgement, definitely it will be there.
Nice. There's a question. I'm not going to bring this up because this is again would you use this or that? But how do you handle this if there are a lot of metrics? Like, is that a problem if you have, let's say you have a device and that device has thousands of metrics, thousands of
okay. That's a lot bigger problem. We can handle like over 4,000 columns for each table. So each device can have over 4,000 measurements. That should be big enough. Yeah.
It's true. Yeah. Usually if that is like, if you have more, you should modularize your application, right? That don't look at it as one big application, but multiple smaller ones.
Yeah, you need you need multiple tables.
Yeah, I think that from that comment, that is more like a special case.
Yeah.
And then
but we do have customers with like 4,000 columns. We do.
Yeah.
Like some connected vehicles, like for some self-driving, they have even over 4,000 columns.
Okay.
Yeah.
Very common for, somebody says here, very common for IoT devices. More than 4,000 parameters, 5,000. I still feel like yes, but then you would say, okay, these are subsystems with it. Let's say you have a car, and of course the car will have more than 5,000 parameters, but then you would not look at just at the car. You might want to look at it like that's the engine management parameters. These are the
management. Battery management. Yeah. You need a few subsystems, right? So each subsystem may just have
Yeah.
1,000 parameters. Then
Yeah.
you need to divide and conquer. For big data, the only way to handle big number is divide and conquer. So
Yeah, that's true.
maybe you have 10,000 parameters. Then you need to divide them into a few groups to handle. Okay.
Yeah. All right. I'm with my notes. I'm empty with my notes, Jeff. What do we want to talk about? Like we have a few more minutes.
I can talk about one more thing is to handle time series data, because now IoT industry, internet, even stock, okay, you need a database to save the data. But besides the database, probably you still need another component, stream processing, because stream processing is very important for IoT devices. Because you connect the data, you want to do abnormality detection, you want to raise an alarm, right? Okay, and also you want to do real-time prediction. So for many systems, besides the time series database, you need a Flink or Spark for your for your stream processing.
Yeah.
And also like for IoT cases, you also need a caching, because you want to know the current location for each vehicle. You want to know what's the current reading for each meter, right? So you can make a decision. So for your IoT platform, for industry internet platform, you need a caching platform, caching component. Okay, and another one is once you connect the data from many devices, okay, put them together on your AWS cloud. Also, you want to distribute your data to many stakeholders. Maybe those stakeholders is internal or external, right? So time series data platform requires database, caching, stream processing, and also data subscription. It's a complicated system. Now, but for our TD engine, we have all those components ready. You don't have to integrate Kafka. You don't have to integrate Spark or Radius. So it's much simple. So sometimes I'm very proud to claim TD engine is not only a time series database, but it's a simplified solution for time series data. It makes your life much easier because we put all those components together.
That's actually, I saw that specifically the stream processing part I saw in the documentation. I haven't looked at it when I tried it out, but basically that means once the data is coming in, you don't need something like Spark or Flink that actually pre-processes the data and puts then that in the database, but you can actually define stream processing within TD Engine to actually process your data.
And also like another good example, like it's data sharing or data distribution. You need a very good feature, like for IoT. For example, like we connect the data from Tesla, okay? Tesla. Maybe we have 1 million Tesla, okay? Every Tesla reported their data into the data center. But Tesla need to distribute those data to its stakeholders. Maybe for battery vendors, they only need to distribute the battery data to battery vendors. Every stakeholder can look at the whole data, just one small piece of the whole data. Like for battery vendor, they can only see the data for battery. For motor data, the motor vendor, they can only see their own data. So you need a very flexible way to distribute your data. Like for our TD engine, when you want to share data with the external stakeholder, you can define what kind of data you want to share by just using an SQL statement. Say, I just want to share first column, second column. I don't want to share 10,000 columns with you. I just want to share 2 columns with data with you.
Yeah.
You can do that. So that's a very important feature actually for IoT or industry internet platform. It's very important.
Yeah. It's so, sometimes it's also with access rights that the sales team should not see all the data that the actual
Yes, you only want to share what you want to share. You don't want to share the whole data. You just give just like a database view, right? You need to give everybody different view. Some people can look at this whole data. Some people can only look at a very small part of your data. You know. So you can protect your data very well. Yeah.
Nice. Yeah. Let me quickly check the comments. There's something I have. That may be something that would be something that you would you use CQRS? I have no idea what that is. By ingesting into a cluster and reading from another. Necessary for timescales and optimizing indices.
Oh, we can do that actually. We can do that. They need a kind of data replication. Like his question is write data into one class, read data from another class. Then you need a real-time data replication. Replicate the data from one class to another class. But of course, you need probably is asynchronous data replication. Maybe there's some 100 milliseconds delay. Okay, depends on your network. Okay.
Okay, yeah, that makes sense. The replication you have very often. Yeah, maybe here in the chat, JR and Sida, maybe you two should get in touch. they said here they are in the same industry. Okay. Yeah, Jeff. Thank you very much.
Okay, no problem.
Everybody in the in the description, I also added links to TD Engine. Again, to Jeff. Give Jeff a follow on LinkedIn and Twitter. It was very, very nice having you here, Jeff. Very knowledgeable. You're a pro. I mean, and you have the passion for it. I really love that. It's time series data is close to my heart as well.
Yeah. Oh, I'm a developer because I develop the software by myself. So I have passion for my own product. Of course.
But you have helpers. I've talked to one of your engineers. So
yeah.
It's
we have over 60 engineers, developers for this database. So many people working on this database. Yeah.
Cool. Yeah. Thanks, Jeff. Have a great day. Have a great day, everybody. Thanks for being here. Thanks for the great questions. Again, check out the description here for Jeff's social media and for TD Engine and the video that I did before that. And then see you next time. Bye.
Okay.
Bye, Jeff.
Thanks.
Bye-bye.